3-minute repair, 16 weeks of performance. For my maintenance guys dealing with abrasive material transfer systems, here's how I helped a paper mill in the Southeast take their bark chute repairs from 3-day failures to 16 weeks of performance and counting. If you're new here, I've spent nearly a decade working with these types of repair and protection systems. From $200 quick fixes to $3 million projects, I share this information in the hopes it can help you in your facility. We're going to cover the previous state of their repairs, the material that I had them switch to, why we switched to that material, how we address the hole itself and how carbon fiber works, as well as how we prepared the surface and what cure times we're dealing with and what we really mean when we say cure time. So 3 days, that was it. And these guys had tens, if not hundreds of holes in their bark chute system. This led to a constant loss of material for them, which meant inconsistent operations and increased spending for their hybrid boiler. These guys ran bark and natural gas. The less bark available, the more gas they had to burn. For them, bark was free, but for the gas, they did have to pay for it. So you can see why they wanted these patches to last. Now with each hole, they'd patch it, and like clockwork, they'd have to go back and patch the patch within about 3 days. I had them change the material they were using, and the result was we took those 3-day patches to 16 weeks of performance, and they're still running. And for them, one of the best parts was the repair itself only took 3 minutes. Now, what material would I use for this and other abrasive environments? Well, with aggressive wear, we need something that's wear resistant. Duh, no shit. For this, we want a material that's harder than steel, and many of us think of steel as being incredibly hard. And for day-to-day life where we see it, a light pole, a truck frame, a hammer, anywhere that you see steel, it is incredibly hard. But for wear, it's not hard enough, and I had them switch to a ceramic reinforced epoxy. All right, cool. Why would I use a ceramic reinforced epoxy? Well, to start, epoxies themselves are generally both wear or erosion resistant, meaning in simple terms, they're very difficult to remove even in sandblasting applications. Now, as I mentioned, a great way to resist wear is to work with hard materials. And ceramic is not that far off from diamonds, which many of us know diamonds are the hardest thing on earth. Ceramic is very, very close to that and about 4 to 5 times harder than steel. So remember, epoxies themselves are already great at resisting general wear. And when we blend them with ceramic, now we have additional wear resistance built in from 2 different points. So what about this hole? You can't paint air, right? And I get that question all the time because seriously, you can't paint air. So what are we going to do? For this, we need something to bridge the gap, help the epoxy hold pressure, because epoxies are notoriously bad at holding pressure, right? You wouldn't make a pipe out of just epoxy. And we need something to help prevent a future blowout right next to the patch that we just did. So here, in addition to the ceramic reinforced epoxy, I had them implement a carbon fiber to help bridge the gap and reinforce the epoxy further. So how does carbon fiber work in a hole patching scenario like this bark chute? First, the carbon fiber acts as a physical layer to help cover the hole, because remember, we can't paint air, so it allows us to get the ceramic reinforced epoxy onto the bark chute. Second, because of the strength of the carbon fiber, this can both hold back the physical bark going through that system as well as the air pressure that's in there. And lastly, let's say that hole was 2 inches in diameter. Often the area around the hole is also weakened. In this situation, I had them reinforce an area that's about 4 inches in diameter. So even if more steel is worn away internally, we've pre-protected a larger area to dramatically extend the life of that repair. Now, a big topic with this is how much surface prep do you actually need? When installing epoxies, cleaner is always better, and I'll stand by that till the end of time. But sometimes the reality is you just can't get it that clean. Ideally, we have a nice clean abrasive blast with a 3 to 4 mil anchor profile. No dust, no debris, so clean that you could eat off it. The reality for a repair like this on a bark chute, a quick wire brush to remove as much debris as possible is all that could be done. But an important note, especially for short-term repairs, epoxies stick great to firm, intact rust. What about cure time? What about it, Bob? This is one of my most asked questions. Nick, how soon can I get this back in service? With this particular ceramic reinforced epoxy, I have an ultra-fast hardener that I had them use. Where many epoxies take hours, even days to return to service, with this one, it was mixed and applied in 3 minutes and returned to service in just 15 minutes. Which brings up a great question. What does cure time really mean for an epoxy? Depends who you ask, and it depends on what we're trying to do, and it depends on what service we're in. Taking the longest time and working backwards, for immersion service with aggressive chemicals like sulfuric acid, I'd want to see a full 5-day or 120-hour cure. For mechanical performance, that can range from 5 minutes for ultra-fast systems to 4 hours for slower but still fast systems. And an important note, return to service is entirely dependent on the epoxy and hardener pair used and the specific service we're going up against. So be careful with the term functional cure, as it may be functional mechanically in 4 hours for a bark chute, but if you throw it in sulfuric acid in 4 hours, you're going to have even more issues not long after. And that's how I completed a 3-minute repair to take patches from 3 days to 16 weeks and counting. I had them clean the area as best they could, select a ceramic reinforced epoxy for its wear resistance, and pair all of that with carbon fiber to reinforce both the hole and the surrounding area to really extend the life of that repair.